Hello and welcome, I'm Sammy K. Powers, and in this video we are going to be looking at debugging tests when they fail. So far we've compiled PHP from source, we've learned how to run the test suite, and we've even created a test and even seen what happens when it fails, but let's get into more details about what we do when the tests fail. So we're going to use our trusty example of our echo basic test that we created in a previous video. And just so you can see what that was, just a refresher, we have this test section, which is basically just a brief description of what it does. So we're testing the basic functionality of echo. We have a file section, which is the PHP script that we want to run, which has the echo with a list of arguments here. Hello, I take args. And then, of course, the expected output, what we'd expect to see when that runs. So if we do make test and set tests equals to echo basic, we should hopefully see that the test passes. Yay. So let's make it fail. Let's be naughty. I'm just going to go to the bottom here and append a smiley face like we've done before, and we're going to make it fail by running it through run tests, and of course it fails. Now if I list the files and I grep for echo, we're going to see that we have these extra files in here. Now we've already kind of looked at the .out file, which is the output that run test saw when it ran the test. So if we were to cat that onto the screen, echo.out, echo basic.out, it says, hello, I take args. There's no trailing space, so my command line is right up against it. Now that doesn't match what we were expecting to see. And if we weren't really sure, we kind of forgot what we were expecting to see, we could also cat onto the screen echo basic.exp, which is the expected, and we can see there that those don't match. One has a smiley face and the one doesn't. There are a couple of other ways we could look at this. One that I think is pretty handy is the diff. There's a .diff, which gets both of these outputs in the same file. You can see that it saw the line with the plus on it, 001 plus 1, that's the line 1, and it was expecting to see this one which had the smiley face. And this can be really handy, especially if you have like a lot of output and there's just like one little tiny thing that changed and it's kind of hard to see, like, oh, the .out file looks exactly like the .exp file, like looks exactly the same. How's this failing? The .diff might be able to show you more clearly, especially with syntax highlighting and things like that. There's also a slightly more verbose way of doing that same exact thing. The .log file, it just has a different kind of output to where it shows you the expected output, the actual output, and it shows you the test failed. That can be kind of handy if you're not comfortable reading diffs or anything like that. Now there are two other files here that are actually executable files. They're not just output files. There's, if you can see, the .php and the .sh. Now the .php, if I just cat that on the screen just so you can see it, what it is it just contains the file section, or the PHP code that actually ran in run tests. And we can actually totally run this through our compiled binary at sappy/cli php and then run this echo basic.php. Now this is not the phpt file, this is the PHP, literally just the file section of the phpt file. So we can just run that directly if we wanted to. And there's also this echo basic.sh. Now if I cat that to the screen, echo basic.sh, you can kind of see what it is. It's a bash script with a ton of junk in it. It's actually just 2 lines long, well, it's actually 3 lines long, but two lines of actual stuff in them. But it looks kind of confusing. And if we run it, let me do that, .sh, it runs basically essentially just the PHP file that we just ran. But you might be thinking, well, that's kind of stupid. Why would you have this giant bash script with a bunch of crap in it when all you can do is just run the .php file? It doesn't make a whole lot of sense for this basic example, but let's make a little bit more of a complex example to see why this is useful. So I'm going to create a new test, and I'm going to call it upload any basic.phpt. Now, one of those things that you pretty much always run into when you've got a new installation of PHP and you're uploading files is you always hit that max file upload setting that you have to change, because by default PHP has always been, for as long as I can remember, 2 megabytes max upload. So why don't we play with that? This is not very useful test, but it's going to help us understand a little bit better some more complex tests. So let's go ahead and write our test, and we're going to call this upload max file size basic functionality. File. So here's our PHP script. PHP, close that out. Oop. I suck at typing, by the way. So we're going to say max equals any. So we're going to get an any setting, and we're going to get the upload max file size setting, and we're going to echo this out, but we're going to use double quotes because I want to put a new line here. We're going to say your max upload is, and then let's put in the max. So basically it's just going to show us that setting. So what you might expect to see is your max upload is, and by default it's going to be 2M if I remember correctly. So let's run this thing. So make tests equals upload any basic, and it passed. So it looks like what we expected. I remembered the default settings properly. Yay. I've been in PHP for a long time. I always have to go in and change the setting, and it's always 2M. But why don't we actually use run test to change the any settings? And the way that we're going to do that is we're going to open up the file again, and then we're going to create a new section called any, and we're going to set upload max file size whoops, equal to, because we're elite hacksaws, 1337 megs. This is going to set the max upload file size to this value. So I need to come down here and change this from 2 megs to, of course, our elite hacksaw number, 1337. Now I'm going to run this again, and hopefully we should get it to pass. And it does. Now this is great and all, but remember, we can run these PHP tests as normal PHP files. So if I were to execute this file using our built-in binary or compiled binary, a PHP, we called it upload any basic.phpt, and I ran it, something is peculiar going on here. Look at this output. It says file, your max upload is 2 megs, but expect to see your max upload is 1337 megs, which is not the same. But if we go up here, it clearly shows that the test passed. And so you might be scratching your heads like, how come when I run it here as a plain PHP file, it's not showing up as the same in run tests? Well, I'm going to show you a little trick here. In the run tests help section, php run test.php --help, it gives us a big list of options. So we have this option --show, and there's a couple different options here. So you could do --show -all -php -skip. This is going to allow us to see each of those sections straight in the console when we run the test. Now, when the test fails, we get these as files like the .exp, .diff, .out, and those can be really useful for debugging tests. But what if you didn't want to have to open the file every time, and you just wanted to see the output straight in the console? If you're just, say, messing with one test and it's giving you trouble, it's kind of handy to add this flag. Now, you might be also scratching your head being like, okay, now wait a minute. We're using make test. We're not running from run test directly. And you're right. We're not running from run test directory. So when we do make test and we set test equals upload any basic, like where do I set this flag? If I do --show like out, for example, this isn't going to do anything because that flag went to make, not to run test. See, make responded. Unrecognized option, show -out. So how do we get this flag into run tests? Well, in order to answer that question, we need to look at the make file. So I've got Atom pulled up here. Let's find the make file. There it is. I'm going to search for the test target. There it is, test target. If I scroll down to this line here, this is the line that actually executes run test. So basically, it's saying whatever the PHP executable is, sending in an any file. This is where it executes run tests with whatever binary was specified in the variables, and it sets the ini files, sets some extensions, all this kind of stuff. And at the very end here, we have this test variable which we get to set. Now, this is handy to know this, because all this is just being appended to the end of this command. So let's take advantage of that. So you already know that we can do make test and then specify multiple tests by adding quotes, right? So we do, say we wanted to do the echo basic .phpt, and we also wanted to do the upload any basic .phpt. So we can run both of those. That's how we send spaces, and we ran both of those tests. One passed, one failed. We already know that's supposed to fail. That's great. So knowing this, why don't we get a little sneaky? So what if we did make test, and for tests, instead of just sending in the test directly, what if we did like add our flag here, --show--out, and then specify our test name? Because remember, this test thing is just being appended to the end of the command. So it's basically like we're just adding this straight to the run test command. So upload _any_basic.phpt. If I run that, now we have some new output. We can see directly what the run test is seeing in the out right here because we told it to. Now we could actually change that command. Instead of show-out, you saw that there was an option there for show-all. What happens when we do that? Well, let's scroll back up. It gives us a lot more output now. Now we can see the PHP file that's being executed. We can see what run test is seeing. We can see the expected. So we see a lot more output here. And if the test failed, it'd give us even more output. So it's kind of handy if you just want to just quickly see what run test is seeing without having to cat all those files and kind of remember like, wait, which one is it? Is the .diff I want to look at? Is the .out? I don't know. This gives you a quick glance, which is kind of handy. Okay, so why am I even saying all this stuff? Well, the original question was, if I run this from the compiled binary and I just run it straight up, I always forget, upload, there it is. And we're definitely, when we run it just as a plain old PHP file, we're getting a different output in the file as the expect, but when we ran it in the tests, clearly they're the same. So something is going on here. Well, if I were to open the test again, you can see this section I added right here, the any section. Run test will actually parse this section and set these any sections for you. This doesn't happen when you run it as a plain old PHP file. That's why we're getting our different output when we run it as a PHP file. Now, you might be thinking, well, I really want to execute this PHP file in the exact environment that run test ran it in. Because say you have a test that's failing and you're like, I just can't figure out why it's failing. Well, let's make a test fail here. Let's change, what should we change? It doesn't really matter. I'll just put a smiley. We're smiles. All smiles today on a new line here. I'm going to run this against make test. I'll throw in the show all just to see what happens. So now we see the diff and we're like, whoa, there's a smiley face here that I didn't expect. So you can see what PHP saw, what it expected to see. That's why the test failed in the first place. So it's kind of handy just to see it straight up. But if you're like, man, I'm running this from my compiled binary and I'm just not able to figure it out. So one more time, I'm going to show you if we run it from sapi/ and then we did upload, and we're running the PHP file, right, that it created. It's definitely saying 2M. What? Well, as we know, run test sets that environment up for us. So what if you wanted to mimic exactly the run test environment, the exact environment this test was run in when it hit run test? Well, you remember that .sh file? Let's run it for upload any basic now. Haha! Now we can see why this is useful. Now we're getting the exact output that run test sees. Not like when you try to run it from just as a plain old PHP file. In fact, if we were to take let's just cat this on the screen, upload basic. Whoop. I guess help if I specified the right file. Here we go. Now I want you to focus on this one part right here. We're executing our PHP script and this run test is already set up for us all the settings that we need in order to run it exactly as it ran it. So it sets the any setting here, upload max file size, to 1337M, and then runs our script as we would expect from our compiled SAPI. Super, super handy. And in fact, we're going to see how this is even more handy for us for debugging. And that's what we're going to do now. So GDB, if you've never heard of it, it is a debugger that debugs a lot of things, including C. And I don't have it installed, unfortunately. So if you don't have it installed, this is what you will do. If you do have it installed, congratulations. If you're on a Mac, you'll probably have LLDB. And it works very similar to GDB. But if you're running Ubuntu, you can easily alleviate this by doing apt-get update to make sure that you have the latest PPA repos or whatever they call them. So we can get our Debian packages. And then we'll just sudo apt-get apt-get install gdb, which is a hard one for me to remember because my mild dyslexia always turns the letters around and I'm always like DGB and it's always like command not found. I'm like, that's not what I meant. Okay, here we go. So now that it's installed, we should be able to do gdb -- version. And sure enough, we have it installed. Excellent. Now, why am I doing this? GDB does not work for PHP files. This is a debugger for C files. So if I were to do gdb and then send it our upload basic, I don't know, .php file, as you can see here, it's like, what is this PHP file you're referring to? I don't know what that is. So I will press enter to continue and see if I can still get the program to run. So in GDB, you just type run to run the program, and it's like, I don't see any executable file. What are you talking about? So we'll type Q and quit the program. So how do we debug this thing? Like, say you've got like say you're really hacking on a language and you really just need a step debugger to go in there and just see what's going on line by line. Well, the way you do that is with this handy.sh script. So why don't we cat that onto the screen again? So we have this upload basic ini.sh. Now, this first line we can ignore. It's just saying, hey, we got a bash script here. This second line is empty. So this third line, all this code right here, the command, we're going to copy that. And what we're going to do, now that it's in our clipboard, is we're going to do gdb -- args space, and then we're just going to paste in all that crap that we just copied from the .sh file. Now, press enter. So we'll press enter to continue. And if we type run, this time it actually ran. And as you can see, here's our script output right here, which is awesome. But this isn't very helpful because we didn't set up a breakpoint. So why don't we do that now? Break. I'm going to specify a breakpoint by referencing one of the functions it's going to hit. So that's zend compile. Oh my goodness. Echo. And it should set a breakpoint. Great. So now if we run the program again, it hit a breakpoint and it stopped. So it's just showing us this curly bracket, which is not very helpful. So let's type list to see our context, and boom. We can see that it stopped right here. Basically, it stopped and waiting on line 4467. So right before this zen.opline thing. So it did hit the function zen compile echo, and we're in the function. We're in the context of this function now, which is really awesome. So this is step debugging through the C code. Notice this is not PHP. We're going through the actual C code. In fact, if I wanted to say print AST, because that's the argument that's being passed in here, we can see that it's passed in as in AST. We can also do print AST kind to see what kind of AST node it is. It's the 282, whatever that is. And so we can type next to go to the next line, and it'll say, okay, I'm going to evaluate this. Should I do it? Sure. Let's type next. And I typed it wrong, so we'll say next. And we can go line by line all the way through. So I'll press C for continue. And it went all the way through the program, and it's showing our output. So we were able to step debug through that whole process. Now, this is by no means an in-depth GDB tutorial. Like, I am not a master at GDB at all. I can do very basic things with it. But I want to show you something that's a little bit more useful in terms of, say you're having a specific problem within a function. So I'm going to info breakpoints to see which breakpoints we have set up, and we're going to delete this first one. It's just number 1. So if I info breakpoints again, we shouldn't have any breakpoints. Great. I'm going to set up a new breakpoint, but I want to specify a specific line number. So how do we know where to stop? Well, say we wanted to stop on the line that was referencing any get. So here I've got the PHP source code pulled up at the GitHub repo. I'm just going to search the repository for any get. And as you can see, there's lots of results for that. It's being used in tests, it's being used in all the things. So how do you find where this is defined? Well, there is this macro. PHP is just full of macros, which are basically precompiled little bits of code that get expanded in place. So it's a little mind-bending. You might want to Google it to kind of look to figure out exactly how they work. But the one that we're looking for is PHP_function, like this. So if I search for that, it narrows our results down to 2. Great. Here's the definition or the header file. We don't need to worry about that one. .h. The one that we really care about is the .c. ext/standard/basic functions.c. And on line 5309, that's the one we want to stop on, because this is basically where any get starts is defined. So let's set a breakpoint. All we got to do is do breakpoint. And I believe it was ext/standard/basic_functions.c. Let's double check and make sure that's right. Basic function.c. Right. And our line number is 5309. So we're colon 5309. Boom. And I said breakpoint instead of break, which is not correct. So let's change that to break. Boop. There we go. Now we have a breakpoint set. Info breakpoints. There it is. Number 2. All right, let's run the program again, see where we stop, and type list to give us a little bit more context. And there we have it. We're right there at line 5309, and we can see we're entering basically the function, the internals version of any get. And we can just keep nexting through all of the code. And here we have zenparse parameters. There's a couple different ways that zenparse parameters is used. This is one of the syntaxes that's a little bit more, it's like a multi-line syntax that uses a number of different macros to actually do it. It reads a little bit better than the other ZPP. They call it ZPP for short. But this is, say for example, we want to look at var name. We could go print var name, see where we are in the program. There it is, upload max file size. That's exactly what we're expecting. String, are we able to print string yet? Did we run that line yet? Let's see. Oh, that's a lot of nastiness. Let's actually go next so we actually run the line. There we go. Now let's try to print string. Print str. Ah, there we go. It's set to 1337. Excellent. So you can see this is very powerful. If you need to really debug, if you're getting seg faults, which is one of those errors that doesn't give you very much information, this is a great way to set up breakpoints before the seg fault happens and step through the program and see what's causing the seg fault. So let's press continue, and we continue and exit the program, and we press Q to exit GDB, and we're done. That is pretty in-depth debugging for tests. When you go line by line in the C code, I think that's pretty in-depth. So now we're pretty much PHP test experts. We know how to compile PHP from source. We can create tests. We know what to do when they error out. We know how to debug them. We should probably put this to the test. Let's actually create a useful test. Let's find a place in PHP source that needs to be tested, create a test for it, and submit a PR and become official internals contributors. And that's what we'll do in the next video.